The Rock ID project. The important thing to understand about this activity is written up here in these three lines here. If a rock sample has straight lines or layers, or if it has chunks of various rocks, or if it contains fossils, then you know it's got to be sedimentary. If the sample has squiggly lines, then it's metamorphic. If the sample has a glassy look, porous, meaning it has lots of little tiny holes like Swiss cheese, or it has random crystals in it, then it's going to be igneous. So with that in mind, let's take a look at all these rock samples. In this first set, we have coquina, granite, and gneiss. The coquina, if you look really carefully, looks like it has all sorts of little tiny shells stuck together. The granite, we have black crystals, and we have brown crystals, and we have white crystals, and they're all various raggedy shapes, no general shape in particular. And then the gneiss, we have these wiggly lines going across. They're not exactly flat, they kind of wiggle up and down. So with that in mind, you can answer question number 1 in the first set, which is true, which is sedimentary, which is igneous, and which is metamorphic. Okay, the next item next to the gneiss is a fossil of some sort. It might be a fossil clam, fossil coral, what else is there? Or a fossil snail. Here I have a fossil coral. What kind of rock is that always found in? Look at the top of the page for the answer. Next, we have a second set. We have schist hornblende, conglomerate, and pumice. So the schist hornblende, we can see that it has wiggly lines going up and down in this regards. The conglomerate, we have grayish brown pebbles stuck in black stuff all glued together. And then with the pumice, if you look really carefully, you can see all sorts of little tiny holes here along the top. So with that information, you should be able to determine which one is sedimentary, which one is igneous, and which one is metamorphic. Third set. We have this stuff called gabbro, then we have sandstone, and we have slate. The gabbro, we have all sorts of different shaped crystals. It's all black, but you can see in some cases the shininess of the crystals in one area versus another area. The sandstone, you can see the nice straight lines. And then with the slate, you don't see much at all. It just looks like a gray rock. One of those is igneous. One of them is metamorphic. One of them is sedimentary. You figure out which one is which. Okay, next to the slate here, we have a petrified tree, a fossilized tree, petrified wood. And if you look at it, it really does kind of look like a piece of wood just out of the woods, out of the forest. It'd be hard to see that as a rock without touching it and feeling it. The question here is, next to the slate is a piece of fossilized tree, here at number 5. Next to the slate is a piece of fossilized tree. This is also called petrified wood, which is true. Now this information is found in your notes, so please turn back to that to find out what is true about petrified wood. Okay, then we have this last set, stuff called tektite. That is rock made from an asteroid impact. It's not the asteroid itself, but it is made by the heat of the asteroid pounding into Earth rocks changing the earth rocks into this stuff, tektite, and throwing it around in the explosion. But it's still pretty cool that is from an asteroid. Or from an asteroid collision, I should say. Then we have basalt. This is the stuff that most of the ocean floor is made out of. Of course, the ocean floor is covered with gook, mud and stuff, but underneath the mud, it's almost all of this basalt stuff. And you really can't feel much there. It feels like very, very fine sandpaper. The tektite has some glassy look to it. You might see some shine at the end here. There you can see a little bit of glistening of the glassy end. The basalt, very, very small crystals. Very, very tiny. And then we have here diorite, where you can see very large black crystals, very large white crystals of various shapes. Okay, so with that in mind, this set is made out of all of the same kind. Either all three are sedimentary, all three are metamorphic, or all three are igneous, which is true. Next question. In the first set, is the metamorphic rock foliated or unfoliated? That is the gneiss here. We can see stripes. So that means that it is foliated. Foliated means striped. Unfoliated means no stripes. Look at the next question. We're asking about the schist hornblende. And that's this one right here. Does that one have stripes in it or not? If it has stripes, then it's foliated. If you don't see stripes, then it's unfoliated. I'll let you decide. And let's see here. The slate. Is this foliated or unfoliated? If you see stripes, it's foliated. If you don't see stripes, then it's unfoliated. Okay, next we want to compare the sizes of crystals of granite. That's this one right here. And basalt, which is this one right here. Which one cooled faster? You do that by comparing the crystal sizes. The crystals are teeny tiny, like sand almost. And in the granite, they're very large. The different colors of black and white and gray are each different crystals. So, obviously, granite is a bigger crystal, but does that mean that it cooled faster or slower than the basalt over here? Look at your notes and figure that out. And that's the end of this activity.